The work energy and power. Question 13. Name the process by which energy is released from the core of the sun. So that is a nuclear fusion. That's right. Good. The next one, describe how this energy, how energy from a sun become a stored energy in the water behind the dam. Basically, you have to explain the water cycle. So here you have to explain the water cycle. So what are the points? You have the heat, the solar energy, which is a heat and the light energy from the sun. Like this is our sun. So heat and the light energy from the sun evaporates this water. Evaporation happen, then it forms clouds. And when it rain at a higher altitude, mountains or higher altitude, it will produce like flowing water, and this water responsible for rivers. Then we build a wall. So when we build the wall, this water will be stored behind the dam, which will have gravitation potential energy. So the points which like how we mentioned this, we'll mention the first thing, the heat energy or the solar energy from the sun absorbed by the water, turn into vapor, and they form clouds. Then when they cool down, it form clouds, and from clouds it rain, allow the water to flow. And that water stored behind the dam will have a gravitational potential energy. So solar energy from the sun or heat energy you can mention will evaporate the water, then it will form clouds, and then precipitation. You can also say use the term precipitation or the rain or the snow at higher altitude. Cause the water to flow, which stored behind the dam having a gravitational potential energy. So this is the point you will mention. Data of two small power stations is given in the table. What is meant by efficiency of a power station? The efficiency is like how much useful energy produced by the power station compared to total energy. Even you can write a formula, they accept that you write efficiency is equal in terms of power. It is a useful power output divided by total power input times 100. Use the data in table 2.1. Explain hydroelectric power station is more efficient. So how to find the efficiency of hydroelectric power station and gas? The useful power that is 25 into 100 divided by 100. So this will be 25% efficient. But for hydroelectric, it will be 30 into 100 divided by 90. It is about 33.33% efficient. So you just have to use the data and find the efficiency of each of them. The useful output, the total output divided by total input into 100. The question 14, this will be the last question for discussion, and then remaining you will solve at the home. The cyclists ride up cycle, then back down the hill. The top of the hill, 14 meter above the ground, the finishing line. The cyclist and her bicycle both have the mass of 90, combined mass is 90. Calculate the gravitational potential energy. So how to get the gravitational potential energy? The GPE, that is mgh. The mass 90, the gravity is 10, and from what height? 14. So 90 into 10, 900 into 14. What's the answer? 9.81 is also acceptable. How much? What's the answer for this? 900 into 14.
Sir, it's equal 12.6 multiplied 10 power 3.
Okay. So it is 12.6 into 10 power 3 joules. Calculate the maximum speed. Now, to get the speed, we should have kinetic energy. We don't have. How we can work out? Because we always assume there is no loss of energy until unless they mention in the question. So this was 12.6 into 10 power 3 joules. When she rolls down, like the bicycle move downward, she will have a kinetic energy at this point. If there is no loss of energy, she will have 12.6 into 10 power 3 joules of kinetic energy. Now we have the kinetic energy because there is no loss of energy. So then we'll work out the speed. So the kinetic energy is gravitational potential. Kinetic energy is half mv square. Gravitational potential energy is 12.6 into 10 power 3. The mass of the cyclist with a bicyclist T. So this is 12.6 into 10. 0.5 into 90 is 45. 12.6 into 10 power 3. 45 is multiplied, the side will be divided. So 12.6 into 10 power 3 divided by 45. And after that, take under root, square root. So 12.6 into 10 power 3 divided by 45 in a root. What's the final answer? Her speed. What's the final speed at which she finished the track, or the finishing point? She crosses the finishing point. 12.6 exponent 3 divided by 45 in a root. 16.56.
16.7.
Okay, it's fine. So 16.7, 16.56, 16.6 meter per second. Then the next part they're saying, in practical, her actual speed will be less. Like we calculated that she will cross with a speed of 16.5, 16.6. meter per second. But in practical, her speed will be less than 16.6. Why? What is the reason for that? Because of the friction and the air resistance. So due to friction and air resistance, some only mentioning energy dissipated will not give mark. You have to mention like energy dissipated by the friction or energy lost by the friction or due to friction in air resistance. So this was question 15. Question 14 from exercise, work, energy, and power. Exercise 2. Next session, we will do the topic pressure. That is the last topic of block 1.